Hello students, in last video we have studied different types of loads, and before going to this video you should watch that video for better understanding. Now in this video we will start with the stresses and strains. Different types of stresses we will learn, different types of strains we will learn. Now first we will start with the stress. First, what is stress? When you are applying any load on a body, that body will get deformed. But before getting deformation, that body resists that deformation. Means, for the best example for that, I'll show this. This is steel wire. Okay, I'll try to deforming that wire, but it is not getting deformed. It is coming back to its shape. Why? Because the internally some force or some load or some resisting force is acting on that body, so that it is coming back to its shape. So this resisting force, we can call it as stress. Now what different types of stresses are present? First one, now, what is tensile stress? When a body is subjected to a tensile force, that time the internally or a resisting force developed by that body, that is called as tensile stress. Now, how we can denote that stress? We'll denote that by sigma, like this. And it is the ratio of applied force to the cross-sectional area. Now to understand this formula, we'll take one body. This is a body and we are applying force over here. This F is nothing but force, and the A is nothing but cross-sectional area of this body. Now, what is the cross-sectional area? You must know what is the cross-sectional area. Okay, to explain that, I'll tell you one thing. If I cut this pen, what kind of shape I can find? If this is, consider this is as a solid one. If I cut this pen from here, what I can see? I can see a shape like this, circular shape. Correct? Now I will take this square bar. This one. And if I cut this bar like this, what shape I can see? A square shape. Now this shape is called as cross section. Cross section of this bar, cross section of this bar. Now here we are getting a circular cross section, and here we are getting the rectangle or square cross section. Understood? Now that A is nothing but this only. Now what is the unit of this stress? SI unit of force is Newton, and the SI unit of the area is meter square. So the unit of the stress is Newton per meter square. Understood? Now next we will take compressive stress. Now here, to understand this, we'll take one body and we will apply a compressive force. When any body is subjected to a compressive force, that time that body undergoes in the compressive stress. That body develop the compressive stress. So sigma is equals to F by A. Understood? Now, next one. Next one is third. When you are applying a shear force, yesterday we have understood, or in last video we have understood that what is shear force. Now, whenever you are applying a shear force, that time that body produce a shear stress like this. If this is the body and it is fixed at the bottom, and if we are applying a force like this, then it is nothing but at the bottom also same force is acting but in opposite direction. Correct? Now this body will get deformed. These dotted lines are showing that the deformation of the body. Now whenever you are applying a shear force, that time that body will develop shear stress. It is also indicated by the sigma F by A. Okay. Sorry. Shear stress is always indicated by tau like this, but unit is same, Newton per meter square. Okay. So this is about the stress. Now we'll come to the strain. Now strain is nothing but deformation per unit length. Deformation per unit length. But to understand that, we will take different types of strains and we will come to know what exactly it is. First one, tensile strain, and we will take one body like this. We will fix that body at the left side and will apply the force on right side. This is a F and cross sectional area of this body is A. Okay. After applying a force, body will get deformed. The original length of the body, we can say that is L, small l, and the change in length of the body, that is nothing but delta L. Delta L. Now, what is strain? Strain is nothing but, first it is indicated by this, and it is nothing but change in length, that is delta L, to the original length. Now in tensile stress, in tensile strain, it is increase in length to the original length. Why it is increase in length? Whenever you are pulling any body, whenever you are applying tensile load, the length of the body will get increased. It will not get decreased. It will get, obviously it will get increased. So increase in length to the original length. Now if we see the next, compressive strain. Before going compressive strain, what is the unit of this? Let us see. Unit of length is meter. Unit of length is again meter. Meter will get cancelled and there will be no unit for the strain. No unit. Understood? Okay. The next is compressive strain. Now, in this, what we will do? In this, what we will do? We'll take a body. We'll take a body and we will apply a compressive load like this. Now, what will happen? Here only I'll show. The body will get compressed this much, isn't it? Now, the original length of the body is how much? L, and changing the length of the body is, that is delta L. Now what will be the strain? Strain is equals to decrease in length to its original length. Got it? Now the same way, next is, third one is shear strain. Okay. In this, whenever you are applying a shear force on a body, changing its length to its original length, it's called as shear strain. Now we'll take one body like this, and it is fixed at the bottom. Apply the force. First we will say that body A, B, C and D. Now after applying F amount of force, B will change to the B dash, A will change to its position to A dash. Okay. Now the angle between this is phi. Okay. Now the shear strain is B dash divided by BC. B dash divided by BC. This is nothing but tan phi, the angle between this. By how much angle it got deviated, this B point to B dash point, that is that angle we can put here. This is shear strain.